This video is about interpreting and drawing box and whisker plots. Firstly, what are box and whisker plots, sometimes just called Boxplots for short? Just like stem and leaf plots can just be called stem plots. It's basically a graphical display of the 5-number summary. So it's a way of showing graphically the 5-number summary that we learnt previously. So you can see the 5-number summary on this one here. This is an example of a box plot, and the lowest value, x min, corresponds to that point there. The lower quartile, sometimes it's also called Q1, is in line with that part there. The median is in line with that line there. Of course, this is a scale. Okay, that arrow indicates this is a scale. The upper quartile, or Q3, is in line with that line, and the highest value, X max, is in line with that. It's basically how it works. So we've got 1, 2, 3, 4, 5. They're the 5 numbers in the 5-number summary. Box plots can be plotted alone like that one, or we can use them together vertically or horizontally, and that's called parallel box plots. And that's very important. Parallel box plots happens when we're comparing sets of data, and that's one of the most useful purposes of box and whisker plots, to compare data. So whether you're using technology such as Desmos or text instruments, Casio, or you're drawing the box plots by hand, there's some steps we need to understand. Let's learn these steps through an example. So we've got test A and test B. So a group of students sat test A, then they sat test B, and perhaps that's a test before and test after. And we'll have a look at their scores, which are out of 10 for this test. Okay, so let's see what happened. First thing I've done, as we've seen before, is put the data in ascending order, and we have 12 bits of data. So the position of the median is what I'm going to go for now. So that's the 6.5 spot, or between the 6 and the 7. So 3, 4, 5, 6, 7. So the median is there between those two. So the median is 4. So we've got our lower and upper set like we've seen previously. Lower set, upper set, and we've got to find the middle of the lower set, so that's there, and the middle of the upper set is there. So the lower quartile is here, and that is 3. So Q1 equals 3. If you don't know these steps, you need to watch the previous video which goes through these. Q3 is there, so that's 4.5. The minimum value is 1. The maximum value is 6. And the IQR is basically Q3, which is 4.5, minus 4.5 minus Q1, which is 3, which is 1.5. So what we can do now is look at those numbers. Which ones form the 5-number summary? 1, 2, 3, 4, and 5. That IQR will be interesting in just a moment. Let's look at the same now for B. Okay, so I've put set B in ascending order. Let's go ahead and find the median for data set B. So the median is the middle, so 4, 5, 6 between the 6th and the 7th, because we've got 1, 2, 3, 4, 5, 6 on the other side, so that'll be 5.5. The lower and upper sets now will be identified. We've got the lower set, we've got the upper set of data here, and the middle of each of those makes Q1 and Q3 respectively. So we've got Q1 is 3.5, Q3 is 6.5, Now the lowest X min is 1, X max is 9. And the IQR, Q3 minus Q1, which would be 6.5, take 3.5, which is 3. So the 5 number summary for this data are these. So what you do, the steps involved, we'll go through those now. We'll have a parallel pair of box plots. I've used Desmos for this. You can see that the first lot of data is plotted in red, and the second lot of data is plotted in a bluey purple color there. So we saw the 5 number summary had the following data. So for the top data there, we've got, so the X min is 1, and you can see on the scale each of these little increments is a half, so 1's there, and the minimum value is 1. So, and that's corresponds with 1 there. Okay, that's 1. And then we have, what we do is put a little line like that, or even a dot, and then we extend this. This is the whisker, as in boxer whisker. That there's the whisker. So now you know where that part of the name comes from, the whisker, because, well, I might as well say it now. This part's the box, and that's the other whisker down there. Hence the name. And we have lined up with 3. We have the Q1 value, the lower quartile, Q1. What we do then, we end the whisker there, and we draw a box like that. It's nice and symmetrical in terms of how it is vertically, not horizontally. But we put a box, we put a line up there to make it nicely proportioned. Then we extend that line across till we get to Q3. So Q3 is 4.5, and you can see it goes to 4.5 there. We put another line there. We connect all that up. Now, what's this line in the middle? That line in the middle is the median. The median, so that was 4. So the median goes there, and you can see, yes, that does correspond to 4. We put that in. Okay, whoops, that went off a bit. So then we extend the next whisker up to the maximum value, which was 6, and you can see that corresponds. We draw the other box plot the same way and have a nice gap. Notice how they share the same scale. That's extremely important. Otherwise, we can't use them for their purpose to compare things. So you can see there, we've got a way of comparing them now, and we've got the values, I guess, in the purple box plot are on average higher. The median, for example, is higher. It's the only average that appears there. It's only the only central tendency value there. So the median is high, which we can say it's like saying the typical value is higher. For the purple test, that was the after test. So on average, they scored higher. Because these are test scores, they scored higher on the second test. And we can also see that the spread of the data, which is really important to talk about, not just the typical value in the middle, but the spread of the data after is a lot greater than it is before. So what we have there is that's the range, because that range is the max minus the min. Look at the two ranges. There's the range for before, and look at it after. It's much broader. So the range increased, the average increased, but also the range increased on the after test. So the other thing too is the interquartile range, which is the middle part there. So the interquartile range is the box, in other words, that middle 50%, and we can see that it's a lot broader second time around. And you can see this is important too, because you know how the 5 number summary works. From the minimum value to the lower quartile is 25% of the data. So each of these segments of a box plot contain 25%. So you can see 25% of the data here is much broader at the lower quarter of the data. In the second quarter of the data, it's broader again compared to the red data, and also the third quarter, and quite a long whisker at the end for that last. So the data is more spread out, but on average it's higher. So we've got to be able to interpret box plots as well. So box plots, if we look at parallel ones, as we know, they can be plotted horizontal, they can be plotted vertically. You see that a fair bit as well. So we just have the scale going up and down. There's no problem with that. In fact, you see it quite a lot. What you might notice here, they've got travel times of people who took the bus compared to cars. And this bus one has a couple of little asterisks on the end, and the car one has one. So those things correspond to the outliers. So outliers can be identified in box and whisker plot. So if we don't identify them, we have what's called a standard box plot. That's called a standard box plot, where we make no attempt to identify the outliers. And that's just like what we saw here. That's if there were any if there were any box plots, we made no attempt to identify them. So you don't see any little crosses or asterisks plotted on there. But this one here, it does have the outliers identified. It had outliers and we identify them. So when we do identify the outliers, it's called a modified box plot. Now, why is it called a modified box plot? What we do is basically we work out where the fences are. Okay, you need to look at the previous video on outliers. Look at the fences are, and anything above that becomes a little asterisk, or sometimes you see a little cross plotted in alignment with the box plot. Where does this maximum end go? Does it go to the fence, or does it go to the highest value that's not an outlier? Well, it's the second one. It goes to the highest value. It's important to note that it goes to the highest value that is not an outlier. So that value there, which looks like it's 33, it must have been in the data set, and it was the highest value that was not an outlier for that. So important to note that. Generally you should try and do the modified box plot, the modified ones, because it does a job at identifying outliers, and we often need to know about them. Remember from the previous video, outliers are important. It could be human error, or it might just be a strangely large or small data set. Outliers can happen on the bottom end as well. What about lastly this set of data here? How can we do this as a modified box plot? Well, I'll speed it up a bit. We'd have to do the usual steps. Ascending order, 5-number summary, which I've done for you here. I haven't put the median in, but we'll get to that in a second. You find in the usual way the lower fence and the upper fence. Okay, that's from the previous work. And we look at the upper fence. Anything above 11 or below -1 is an outlier. From the data, there was one piece of data, 12 was outside of that range, you can see there. So we would basically put our box plot up to the there's no worries at the bottom, there's no outliers at the bottom, but at the top we look at 9, because 9 was here. It's the biggest bit of data that is not an outlier. So the correct modified box plot would be like that. It would end there. The median, by the way, was 5, and we would put a little, either an asterisk or a cross, to denote the outlier.